Good morning. I'm Jeffrey Plant. I'm the Managing Director of PMA's Canadian operations with offices in Montreal, Toronto, a growing presence in Regina, and our newest office in Vancouver. I'm going to be speaking about the infrastructure challenge facing North America this morning, but before I do, I'd like to share a little bit about my experience with NetPoint. I've only recently joined PMA, but I've actually been a NetPoint user since 2014. I first encountered NetPoint at the 2014 CPM conference in Orlando, Florida. And shortly after that, I had the opportunity to lead the scheduling team on a $2 billion bid for an offshore oil platform off the coast of Newfoundland, where we used NetPoint to consider a range of construction phasing options and use it as a very effective tool for communicating with senior management about the advantages of various approaches to building this very complex project. It was just a super effective communications tool. After that, I joined Infrastructure Ontario, where I had the opportunity to introduce NetPoint to Infrastructure Ontario for use in the planning of some of their major infrastructure projects. For those of you who don't know Infrastructure Ontario, it is the project delivery arm of the Government of Ontario, and Infrastructure Ontario has delivered over 100 major infrastructure projects in the last 20 years using the P3 model. Most recently, I was the project director on the Champlain Bridge project in Montreal. This is a $4.5 billion P3 project. I was in that role for 6 years, and at the concessionaire level, we use NetPoint to communicate the contractor's 14,000 activity P6 schedule to the investors to give them comfort that the project was proceeding in a good direction. So I'm going to talk about that a little bit more today, and let's get on to what I'm going to talk about. So there is a huge challenge in North America at the moment with respect to infrastructure. There's a lot of pent-up demand. What I have on the screen is a slide. It's a few years old. It's from McKinsey. And in 2015, they were noting that the annual global infrastructure demand is about $3 billion, and that there is a considerable shortfall in the amount of spending that the world is investing in infrastructure. And it was estimated back then to be around 33%. So we are in North America well aware of the infrastructure needs, and these needs are being addressed both in the United States and in Canada by major infrastructure spending plans of both governments. So in the US, we have the $1.2 trillion infrastructure bill that was signed into law in November of 2021 that is going to provide $550 billion of new money to invest in US infrastructure. And there's a very similar program in Canada that's being led by Infrastructure Canada and the Canadian Infrastructure Bank to invest comparable sums into Canadian infrastructure. So as somebody who's been involved in the management of major projects for most of my career, and in particular for the last 25 years on major P3 and design build projects, this is what I think owners want. And it's not necessarily what they always get, but this is the goal. We're looking for well-conceived projects that have strong public support, that are predictably funded, that are efficiently, the program delivery method is efficient and effective. They have realistic schedules. They want their projects to be delivered on time and on budget with great quality and no claims at the end of the day. And that is a big challenge for delivering these projects, particularly in the current climate where we will have over the next 5 years and most likely over the next 10 years at least, many large projects proceeding simultaneously across North America. We're facing unprecedented cost escalation at the moment. The construction industry is suffering from a lack of labor, human resources. There are supply chain issues that are creating shortages of materials. Contractors who have bid fixed price lump sum contracts are being hurt quite severely in some cases by the inflation and the supply chain issues and escalation and so on, which is causing declining profitability. That is, in some cases, encouraging a consolidation of the industry, which means there'll be fewer competitors, which potentially is inflationary in itself. So there are a lot of challenges facing owners and government agencies who want to implement major projects under the current commercial environment. All I have to say is that we're moving from a buyer's market to a seller's market. And that's to say that contractors in today's market are able to be much more selective as to which projects they decide to pursue and to actually bid on. And for owners, that means that their projects have to be better planned and better presented to be attractive to potential bidders. And in order to do that, that process starts, in my opinion, with having a realistic schedule, a deep understanding of the project risks, and a realistic budget. When we look at how a lot of clients, public agencies and private clients plan projects, they often start with a critical path method chart that, well, they start with a need, of course. They start with a scope definition and an understanding of what the project is. And then once they have an understanding of that, they can prepare a schedule. And the tools that are normally used are Oracle's Primavera P6 or Microsoft's Project to prepare critical path method charts that look a lot like the one I have on the screen. This one is taken from a specific project. It is a $10 billion wastewater treatment project with a 16-year implementation program. Very professionally prepared schedule, but difficult to follow for senior managers. On this particular project, we took that 16-year program and using the tools that Tim Mather just described in the previous session, prepared a NetPoint schedule that was much easier for the decision makers to understand. They could see the entire 16-year program on one page. We could do interactive planning with the schedule. We could move activities forward or backward. We could look at different options where activities might happen in parallel. And at a senior management level, this kind of tool is just, it puts scheduling back in the hands of the people that it was originally intended for. And that's to say the users and the planners, as opposed to having to have highly trained, highly skilled scheduling experts to manipulate a large schedule. So this was a very effective session that we did. Now, owners want to be assured that when they award a contract to a contractor, that contractor has fully considered how that project will be delivered. And increasingly what I see, particularly in the public sector, are scheduling specifications that are very complex. They require the contractors to provide an enormous amount of detail. And I guess the question I put to the group today is, are these complex scheduling specifications providing the owners with the assurances that they desire? I suspect in some cases they are not. What's happening? Owners are using these complex schedules to monitor progress and to protect their financial commitments and to try to avoid claims as much as possible. So contractors are wise to this. They design their schedules to support successful delay claims. They put more activities on the critical path than maybe really belong on the critical path. So owners then respond to that by adding scheduling, cost, resource loading requirements to make it increasingly difficult for contractors to succeed with claims. And contractors respond by becoming more adept at scheduling and claims management, and by basically putting parallel claims teams on projects very early on in the development of the construction programs. What I've seen on some recent projects that I've worked on is that managing the schedule can become a project in itself, and it can become somewhat isolated from the actual planning of the project. When the owner asks for very detailed schedules, the contractor has to put a scheduling team on the schedule. And if the owner asks for monthly updates and for cost and resource loaded schedules, it takes a lot of effort for the contractor to do these updates and to manage the costs and resource inputs that sometimes owners require. So sometimes what happens is that you get the official schedule, which is the one that satisfies or attempts to satisfy the owner's scheduling requirement. Often that schedule becomes an end in itself, and it isn't necessarily that closely connected to the reality of what's going on in the field. Then you've got the contractor schedule, which many times can be quite optimistic. You know, you have to remember that on many of these large infrastructure projects, the successful contractors are selected because they had the lowest price. And in order to convince the contractor's senior management team that that price is the right price, contractors normally have optimistic estimators. For them, the glass is always half full and everything is possible. The people who deliver construction projects tend to be a little more pessimistic, and they get handed the project and said, okay, we've won this $5 billion project, go ahead and deliver it in a certain period of time. And the normal reaction for the construction staff is, you said we could do what and how long? And that that leads them to, you know, to basically tear apart the bid stage schedule and to basically reassemble it into something that makes sense. Just a little side anecdote on this. I worked on the Port of Miami Tunnel project, and initially the project delivery team was told that they had 55 months to build the schedule. I was involved in the early stages as the technical director and responsible for scheduling on the construction team. And when we first put together the schedule, we had an 84-month schedule. That was going to be problematic. We had to bring it back to 55 months. And we did it by doing some very intense value engineering, using an external facilitator and a formal 1-week-long value engineering process involving about 35 people. And we found a number of ways to do work in parallel and to change the construction sequencing and to force the schedule back to 55 months. Actually that project team won an award from SAVE International for the value engineering project of the year. But anyway, I digress. The contractor schedule is still going to be optimistic. 55 months was still a very aggressive schedule in the Port of Miami tunnel project. The area managers who had to deliver it, they thought it was optimistic, but possibly achievable. And you know, they worked hard to actually deliver it, which they did in the end. And then you've got where the rubber hits the road is the actual schedule, which the area managers communicate to the superintendents and the foremen and the tradespeople on site. So this is what an official schedule looks like. This is a $3 billion project. It resembles somewhat the construction stage of the Champlain Bridge project. The Primavera P6 schedule is required by the client. No activity should exceed 14 days duration. There were some exceptions permitted, but in general, the schedule had to be broken down into activities no longer than 14 days. This was a 5-year project, so a lot of activities. The contractor was able to break the project down into 14,000 approximately activities over 60 months. When printed out on 11 by 17 paper, that schedule took about 350 pages to print out. Very difficult to analyze the schedule without specific scheduling tools, similar to what Tim showed in terms of identifying logic errors, missing logic ties, negative float. Just you really need with a big P6 schedule to use the tools that are available in P6 and sometimes third-party tools that are available to really understand the schedule. And that is the purvey of scheduling experts who do this every day for a living, and it's not something which project managers normally are able to do. And what happens on these big schedules, and again, I saw this in the Port of Miami, and I also saw this in the Champlain Bridge, is that it's very difficult for the contractor to get a baseline schedule that is accepted by the owner. And on these big schedules are very complex. You're scheduling in the first 60 days of the project work that's going to take place 6 years, 5 years, 4 years down the road, and it's almost impossible to accurately predict what might happen 3 or 4 years down the road. And in the end, if you don't have a good baseline and claims arise, you get into a whole dispute over who is responsible for the delay, and you end up at that point, typically both sides retaining forensic scheduling experts to tear apart the schedule and support the claims, and it becomes a very, very complex activity. This is the contractor's schedule on the Champlain Bridge project. This is a one-page Tylos schedule. This is a Trimble product now, and on this schedule, reading a Tylos schedule, you have the geographical location on the x-axis along the bottom. So this is a bridge that is about 3.3 kilometers long, just over 2 miles long. And then you have your duration, your dates up the y-axis on the left-hand side. So you read the project schedule basically from bottom to top. And what this project said is that substantial completion would occur December 1st, 2018. So that was the contractor's schedule. How it actually got delivered is in the trailers of the construction manager teams. There were whiteboards on the wall, and on a weekly basis, the area manager would go through the different geographic locations. In this case, frame 1, frame 2, frame 3, frame 4 are shown. These are components of the west approach of the bridge, and the days of the week across the top, and which crew is going to be working in which area. And then on the left here, the restricted work areas. This is where painters were working at certain times and where these areas would be restricted. Days of the month down the left. And then on the bottom right, you've got a method statement. Now, there were formal method statements produced on this project that were very, very professionally done. They would be, anywhere up to 50 to 100 pages in some cases for complex operations. But you have to take that complex method statement and the carpenters, the iron workers, the mechanical trades, everybody has to understand what their role is. So you get into these scrums basically where people are talking about who's going to do what the sequence is. And this is where you get, this is where the work happens. You plan it at this level in the site trailers, and then the crews go out and they build the job on site. Well, what I liked about NetPoint, and the fact that, and what I like in general about the graphical path method that NetPoint is based on, is that it's very visual. It's intuitive, it's dynamic, it facilitates what-if analyses, and and you can do real-time planning with it. So on the Champlain Bridge project, now my role on that project as a project technical director was working for the concession company. So I was managing essentially a $3 billion construction contract that was awarded to a consortium of four major firms. So our concern at the concessionaires level was whether or not, was when the project was going to be available and put in service, because we had to hire people to support the operation of the bridge and the related infrastructure. So the question was, when should we be bringing people on? So back in 2017, we took the contractor schedule, which, as you saw in the Tylos chart, had a substantial completion date of December 1st. We took that schedule and we basically simplified it into a series of simpler activities that showed us that the contractor had a fair chance of finishing the work by the end of November, and then allowing a month for final certification. But there is one activity on the critical path, and again, Tim was talking about float and total float and things like that. The way that you read this NetPoint schedule is that the dashed lines, such as I'm pointing at here, between finishing and paving, this shows that there was several months of float between the completion of frame W2 and the start of paving. There's a little bit of float here between finishing of frame W1 and paving. There's a lot of float between frame W3 and paving, and so on. But when you get down to the cable stayed bridge portion of the bridge, which is the center portion of the bridge, there is no float. This is the critical path. And there was an activity that started on October 22nd. It was to finish on November 16th, which is the final paving of the final section of the bridge. And that's a high risk activity because in Montreal, temperatures tend to fall below 32 degrees Fahrenheit or 0 degrees below freezing in early November. And paving operations typically end by the middle of November. So this schedule showed that paving was going to go right up to the very end of the possible paving season. And if the paving wasn't completed, it would not be able to start again probably until June of the following year, by which time the project would have thawed out enough to permit paving. Maybe in May, but May or June. So a 1 week delay in this paving could cause potentially a 6-month delay in completion. So we identified that back in 2017, and I guess it may not surprise you to know that that the bridge did open to traffic 7 months later than was originally planned. Okay, so so when we're identifying project risks, what I showed you on the previous NetPoint slide is that there was a risk that we were able to visually identify using NetPoint and to reach conclusions about likely or most probable start of the project. And that's done, that was done qualitatively. It wasn't done quantitatively, but there are ways to quantitatively assess schedules, both in terms, in terms of completion dates and probability of completion dates, and also to quantitatively assess the probability of a budget being achieved. I'm just going to switch gears a little bit now and talk more about project risks, because this is an important aspect when you're planning a major infrastructure project. It's all about understanding the risks so that you can adequately plan a schedule and so that you can adequately prepare a reasonable, realistic budget. These 10 risk areas that I've highlighted on this slide come from some work that was done by MMM Group, who are now part of WSP. And it was a study done for Infrastructure Ontario back in 2015. It's a little bit more detailed and applicable to public infrastructure projects and some of the other kind of risk categories that I've seen from organizations like PMI. And I throw it out here. I think it's a good guideline. If you're planning a project, these are the categories of risks that you might want to consider. And the first step in doing risk analysis is to prepare a qualitative risk register. And the first step in doing that is understanding how you're going to classify your risks. So the risks can be, again, there are many ways of doing this. This is one method that I've been using on projects for the last more than 20 years, 25 years probably, where we classify risks according to their probability of occurrence and to the impact should they occur. So we can look both at cost impacts and at schedule impacts. On a $3 billion 60-month project, you might consider classifying risks like this, which would mean a minor risk, a low risk. It would be something looking at the bottom here that would have less than a 1-month impact in schedule and less than $1 million cost impact. Getting up to a high risk would be something that might cost you $10 million and result in a delay of over 9 months. Now, these risks are kind of additive or cumulative in some ways. If you have a schedule impact of 9 months and you have liquidated damages for failure to complete on target, in the case of the project that I'm referring to here, the liquidated damages were $400,000 per day, so $12 million a month. A 9-month delay is $108 million cost impact. So that, you've got to, the liquidated damages calculation is very important when you're assessing the impact of risks, and especially if you're a contractor bidding a job. So normally what we do is we do a qualitative risk register. What I've done here is I've basically shown you one potential risk from each of the 10 categories that I identified previously. Some of these are, you'll see the risks differently whether you are an owner or a contractor. The risks that I'm looking at here are the risks that a contractor would are expressed in the way a contractor would see the risks if a contractor was preparing this type of schedule. And by using a fairly simple Excel spreadsheet and doing a heat map, you can see where the major risks are. So we calculate a risk score and a cost score, which is basically the probability of occurrence times the cost impact. So if I look at the first risk here, the project may be canceled if the bids come in too high. Probability of that occurring is low. The cost impact is low. So 1 times 1 gives you the cost risk score of 1. The schedule impact is low. There is no impact to the contractor if the project doesn't go ahead because he doesn't have to worry about completing it. So the probability of occurrence in this case was low, so the risk score is low. If I look down below at utility relocation delays, probability of occurrence of utility issues is high. The cost impact is medium, so 5 times 3 gives you 15. But the schedule impact could be huge, so 5 times 5 gives you a very high risk. And I know some of our clients average these two. They take the average of cost risk and schedule risk, come up with a blended risk factor. Personally, I don't recommend doing that because I think it averages down some of your major risks. And sometimes you can have a major scheduling risk, which is not a major cost risk, but it still needs to be carefully managed. So once you've done this sort of qualitative risk register, and I guess I'm just throwing this up here as a reminder, because frankly, in a lot of the projects that have run into large claims in recent years, the root cause of those big claims can often be traced back to an inappropriate allocation of risks. So if you are the owner, I know it's tempting to try to put all the risks that you can identify onto the contractor, but sometimes, the contractors just are not able to manage certain risks, and they are best managed by the owner. So please, when you're planning your projects, please assign the risks to the party who's best able to manage them. Now, what I've said so far is a qualitative risk assessment, and a qualitative risk assessment will give you, allow you to focus on the risks that can hurt you the most when you're implementing a project. It will allow you to formulate mitigation strategies. It will allow you to update your risk register on a monthly basis and produce a cumulative risk index that will give you some idea as to how the risk profile is changing over the life of a project. And all of that is really useful information, but you can take it a further step or another step forward, and that would be to do a formal quantitative risk assessment of both your costs and your schedule, or your budget and your schedule. The benefits of doing quantitative risk analysis are somewhat different whether you're the owner or the contractor. If you're the owner, you can retain independent cost estimators, quantity surveyors to do an excellent quality deterministic estimate and give you a number that'll say, okay, we think this project is going to cost $500 million for sake of argument. What you need to understand is the variability around that $500 million estimate. Is it 500 million minus 20 million, 500 million plus 50 million? What is the sensitivity? And you can get to a probabilistic estimate of what your real cost might be, or what your contingencies and risk allowances should be on a project using quantitative risk assessment methods. Same thing with schedule. By doing quantitative schedule analysis, you can come up with a more confident estimate of how long it's going to take to do this project, or the project that you have in mind. Another area that certainly in Canada is very, very important, very common, is this value for money analysis. And the value for money analysis has been used on major projects to help select the right project delivery method. And in many cases, the value for money exercise talks about the difference in how risks are managed by the public sector versus the private sector. And it could be very useful when you're doing a value for money analysis to use some quantitative methods to estimate that risks. Typically, I find that the value for money analyses have undervalued the risks attributed to contractors, and as a result, show in many cases a huge advantage for doing projects in the P3 model versus other collaborative or traditional project delivery using other project delivery models. So I think we can get better value for money if we were doing quantitative risk and cost estimating. And for the contractor, what quantitative risk assessment does for the contractor is it helps the contractor understand the potential cumulative value of risks. If I flip back to my risk profile quantification, if I have a bunch of risks that are all rated 1, but if they occur simultaneously, if I have and if they tend to be sequential, if I have 10 risks that each are going to delay my project by a month, then suddenly I might have a 9-month delay if the risks occur sequentially. So by doing quantitative risk assessment, you can basically understand better the cumulative effect of risks which might it might be discrete risks that you've identified, but they may have interrelationships among them that make them actually bigger than what you first anticipate doing a qualitative model only. And of course, for all parties doing quantitative risk and schedule assessment, you get a better forecast of completion, defensible contingencies. It really forces you to think through the project in greater detail. It adds discipline. And you can't do these in a vacuum. You need to have the broader project team involved, so you get better collaboration at the outset of a project, which can be very valuable. When we're talking about how do you do these quantitative cost and schedule analyses, and we're seeing some evidence now that some owners are introducing quantitative cost analyses into their procurement models. This is we've seen this recently with the procurement from Infrastructure Ontario and Metrolinx on the Ontario Line project. And there's not a lot of experience in the contracting market in doing quantitative cost and schedule analyses as a component of a bid, as a required component of a bid, or as a required component of a project delivery. So I'm going to spend a few minutes here and just going through a little bit about how you do these. And it's a very soul-searching exercise. It takes time, it takes focus, and it takes commitment to do a quantitative cost and schedule analysis. But what you're basically doing is you're developing a simplified cost model in the case of your cost risk, and you're developing a simplified schedule. Now, at PMA, we like to use NetPoint to develop that simplified schedule. We may take a contractor's bid schedule, which may have 2,000 activities, and condense it down to maybe 100 to 200 activities. We use a lot of hammocks, which is a term that Tim described earlier, which is a sort of a wrap up of a number of sub-activities. So we break the schedule down. We typically look at no more than a level 2 schedule, for those of you who are familiar with that terminology. And we have a simplified schedule and a simplified cost model with a manageable number of activities. And then we go back to our cost estimate with, let's say we have 100 activities. We assign a cost to each one of those activities that totals the project budget. And then we estimate for each one of those activities whether the deterministic estimate is plus 5%, minus 1%, minus 10%, plus 20%, and we assign a variable distribution to each cost that is estimated. And that effectively is 3 additional columns on the qualitative risk register. We do the same thing for schedule. We say for each one of these activities, it has an expected duration of 30 days. Is that 30 days, is the most optimistic scenario 25 days? Is the most pessimistic 40 days? And we assign a range for each one of those activities. And that's the hard part of doing this type of modeling, is getting those deterministic values changed into a distribution for probability analysis. Once you've done that, then it's just a matter of using tools like NetRisk, which is our PMA product. Many of our clients use another product called @Risk for risk analysis, very similar algorithms in both products. @Risk focuses only on costs at the moment, whereas NetRisk will do cost and schedule analysis. So if you're a contractor and you've just done this sophisticated modeling, at the end you have to decide, do you believe the results? And this is where a lot of experience comes in, and you need to, it's just like, if you're designing something, if you're designing a structural element and you've plugged all your values into the computer, and the computer tells you that you need a 36-inch wide flange beam, and you've got a 10-foot span and nothing on top of it, you might say, gee, that looks like an awful heavy beam to put on that short span. So, you know, it's important to do to use judgment and to assess the output. The kind of output that you get on a quantitative cost analysis is something that might look like this. And what you're seeing here is a probability distribution of your costs across the bottom. What this is telling you is that your deterministic value, where you have a 50% chance of exceeding it and a 50% chance of coming in below it, is $370 million. So that's the center of your distribution, is $370 million. Now, if you're a contractor and you're looking at this distribution, down the right-hand side here, we have a bunch of numbers that correspond to the probability of achieving this estimate. You know, if you were to bid the job at, let's say at the top number here, 352 million, what this cost model is telling you is that you'd have a 1% chance of completing the project for 350 million. You've got a 10% chance of completing it for 360 million. You've got a 50% chance of completing it for 370 and a 90% chance of completing it for 381 million. Now, if you are the owner, you want to be looking at the bottom of this range. You want to be looking at, you know, if there's a 90% chance that this project is going to cost 380 million, you want to be budgeting 380 million. If you're the contractor and you have this distribution, you're probably going to be bidding it somewhere up in here. Now, in this particular model, if I had an expectation of making 5% profit on 360 million, that would be 18 million of profit. So if I was prepared to risk my profit to make sure that I succeeded in bidding this job, an aggressive bid would be, you know, if I look at 360, my profit, if I give up my profit, if my cost is 360, that's equivalent to me having bid the job at about 380 million. So I might bid the job at 360 million, knowing that the worst case scenario is that I won't lose any money, but I'd have to assess the quality of the contract documents and my knowledge of the owner that I'm bidding on to determine whether or not I think I have a chance of making that money up through claims and remaining whole. So this is what the race to the bottom approach of competitive bidding does to contractors. It basically forces them to take an optimistic view of risk and bid projects at the low end of the scale. On a schedule basis, this is consider this an example of a situation, whether it would be an industrial complex, you can think of an oil refinery or a steel mill, or in the infrastructure, civil infrastructure side, this could be a lane closures on a major bridge where you're going to be doing a deck replacement or expansion joint replacements on a bridge. And you've got a 30-day maintenance shutdown or a 30-day window to accomplish a lot of things in a short period of time. So this particular quantitative risk assessment, it represents that type of scenario. And here we had a contractor who said he could do the work in 30 days. Well, we had a 30-day maintenance window, and that maintenance window would end on July the 20th, in this case, 2 years ago. And the contractor said he could finish in 25 days. So this is where the contractor said he could finish. When we did the quantitative risk analysis, we thought that there was basically a 5% chance that he could finish in that period of time. And our model basically showed that the 90% probability was way over here. It was 20 days after the shutdown ended. We figured he had a 15% chance of completing the work within the shutdown window. So this is, this is important information to know if you are the owner, because you have to consider the consequences of this delay. If that shutdown cost is costing you $100,000 a day, either in lost income or standby time for staff or lane rental costs in the case of a civil project, that 20-day delay could cost the owner $20 million in lost revenue. So, these are important things to know. In this case, our recommendation to the owner would have been that you not select that contractor. He does not have enough resources allocated in a sufficiently developed schedule to actually be able to deliver what he has committed to deliver. So this is how quantitative schedule analysis works, and it can be a super effective tool when combined with NetPoint for visual communications. So I'm just about to wrap up here. I hope if people have questions that now would be the time to start asking them. Just to essentially conclude what I hope I've shared with you today is that NetPoint can be a very effective tool for communicating what sometimes are very complex scheduling sequences that are otherwise quite difficult to present and to understand. And net risk, when used in combination with a high-level schedule, such as we produce with NetPoint, can also be a very, very valuable tool for planning, both for contractors and for owners. And when you use those tools together, you can keep updating these tools throughout the project and basically managing your project with much simpler information in virtual real time. It's much easier to update a 100 activity NetPoint schedule than it is to update a 14,000 activity P6 schedule. But from a management point of view, you might actually get better information from your 100 activities than you do from the 14,000. So together, I hope we can meet the infrastructure challenge in the coming years. And we look forward to taking on that challenge. So do we have any questions?
Yes, I have some questions for you. So the first question is, what are some examples of risks that might be assigned incorrectly to a contractor?
Well, utility coordination risk is often a big one. Utilities are separate entities. They often don't report to the owner either. But getting utilities to move utilities, underground utilities, whether it's sewers, water main, electrical conduits, communications cables, overhead or underground, if they're in the way of your project, you need the utilities to engage, and you need them to move those utilities to make way for your work. And that is a risk which is very difficult for contractors to manage. Another one is environmental permitting. Now, in both the US and Canada, we have fairly complex environmental assessment and environmental review requirements. If the contractor is required to get environmental permits that satisfy all of the conditions of a NEPA study or a Canadian environmental assessment study or regional environmental assessment study, it can be sometimes difficult for the contractor to assess all of these, because sometimes they involve intervention of third-party stakeholders that are difficult for the contractor to manage. And I'm thinking specifically if it's a state or federal government or provincial government owner who transfers risks for municipal permits to the contractor doesn't often have much leverage with municipalities to get complex permits. So those are two examples that I can think of off the top of my head.
Okay, so the second question is, are public-private partnerships managed differently in Canada versus the US?
Well, that's an interesting question because private-public partnerships are not managed consistently across the US because there really isn't a a central agency that does projects. So P3 projects, the way they're implemented does vary from state to state and from jurisdiction to jurisdiction, sometimes within states where you have municipal P3s or transit authority P3s that are administered more at the municipal level. So there's a lot of variation. What has been interesting in Canada is that on a provincial level, many provinces in Canada have developed provincial P3 project delivery bodies who are not just limited to P3 models of delivery, but the P3 model of delivery has proven to be very effective for public sector projects in Canada. So when you get agencies like Infrastructure Ontario that has delivered over 100 P3 projects very successfully over the last 20 years, that agency has a lot of institutional knowledge built up. They've got templates, they have procedures, they have well-qualified, experienced staff who are familiar with implementing these projects. And the result is that in the province of Ontario, for instance, the construction industry is quite familiar with Infrastructure Ontario and their project delivery models. And they've worked with them, they know what to expect. So when a new project comes up, there's not a big learning curve. So a lot of that is just experience. And my advice to agencies who have not done P3 projects in the past is to engage consultants who have advised other agencies on successful implementation of P3 projects, and take advantage of the experience that the consultants can bring to your project. And that's the best advice I can give. And there are many firms now across North America and Europe and Australia, New Zealand, with a lot of P3 experience and other major project delivery models. And we're seeing more of a movement now to more collaborative models. We're seeing agencies considering what we're calling progressive P3, where the developer is brought on before the costs are finalized, similar to progressive design build, where the contractor is brought on earlier and then the price is negotiated as the contractor develops the design with his team. So yes, there are differences. They're fairly subtle. P3 means a lot of things to different people. We see fewer and fewer full design, build, finance, operate, maintain, rehabilitate, transfer P3s. We're seeing more design, build, finance ones in the marketplace. But I think that the knowledge of agencies and the knowledge of contractors is the highest it's ever been, and in both countries, I think we understand the benefits of the model and also some of the challenges of the model. And I will just add one last point: not all states yet permit P3s, and that's been a barrier to the use of this model in some jurisdictions in the US.
Okay, the third question we have is, did you experience difficulty trying to have a frank and robust discussion regarding risks on public projects? Leadership on public sector projects are sometimes concerned that these discussions could impact public support.
No, I don't think I've had that problem. And in working directly with public sector clients, my experience has been, at the staff level, that they want to know the risks. I mean, sometimes the discussion can, lead them to question their initial estimates, and sometimes that can be problematic. Where if a project has been announced publicly and there's been a number associated with it, quite often that number gets stuck in the minds of the public and becomes difficult to walk that number back. I think that creates sometimes a very difficult political situation where you've announced a $10 billion project that suddenly is going to cost you $20 billion, and that becomes difficult to deal with the public on. And there are lots of examples of that sort of situation across North America. So, my advice to public sector staff is get your numbers right at the beginning, and the way you do that is you do a formal assessment of the risks, and you do it in a comprehensive manner. Experienced agencies like Infrastructure Ontario do that explicitly. They hire external consultants to help them come up with basically an unbiased assessment or unbiased identification of the risks. They use workshops to assess those risks and come up with value for money estimates, but it's really done on an independent, unbiased approach, and I think that's good advice for any public sector agency, is that have that fulsome discussion at the outset.
Okay, I have one last question before we head to the next session. So in your experience on the risk efforts, did you find that the project participants were familiar with the risk process, or were you required to develop some foundational understanding of the concept at the beginning?
Yes. What I find is that a lot of contractors and owners are familiar with qualitative risk assessment, but not so much with quantitative. So whenever we do quantitative risk assessments, there usually is the need for some training and development of understanding. It's growing, but it's still not it's still not common for owners and contractors to do quantitative risk assessments, either on cost or schedule. But it's every time we do one, we have a new group of people that understand the benefits of doing it. So it's a growing area. Thank you, everybody, for participating this morning.